to start talking about user interfaces in Java. Just to sort of refresh our memory, I mean, just about every app that you have is going to have some kind of user interface. What we have done in our example so far is we've sort of replaced the user interface with the, quote, test class. All right? So in other words, in a user interface, you would accept the values from a text box about someone's name, and maybe there'd be a drop down for age, and so on and so forth. And then that would get fed to the object, and then the object would do its thing and spit out the results, and then it would display the results on the user interface. So in the test class, we hard code stuff because that's about the only way we can do it, the easiest way we can do it. And it's good we could hard code and run it through a variety of tests to test the various conditions to make sure we covered it all. But again, that is getting sort of the basic classes correct. What we want to do now is we want to connect it to a user interface, because that's really how an actual application will work. There'll be a UI that handles getting the data, giving it to the objects in the manner in which it's expecting and understands, then taking the results and displaying them sometime on a page. You want to have a very clean separation from these. The better that you can separate between the user interface and the business logic, the better off you'll be. All right? But again, we got to walk before we can run. So the first example, we're not going to do anything fancy. We're just going to pay attention to the user interface and see how it is structured and how it's set up. So let's go and let's download. We're also going to see a good example of why we have things called interfaces. Now again, it's just really a coincidence. You know, we talked about Java interfaces a few classes ago, and now we're talking about user interfaces. It's sort of just a coincidence that the word interface appears in both of these. That being said, we're going to be using Java interfaces and creating our graphical user interfaces if it isn't confusing enough for you so far. All right, so I'm just going to show you this very simple example, and then we'll go on to more involved examples. It is approximately 150 degrees up here. Yeah. Okay, we're going to look at two examples today. This one, everything is in the GUI in this example, which isn't a particularly good programming strategy. For the most part, we want to have a good separation between what is in the GUI and the business logic or the problem logic. In this case, though, since this is our first example, we're going to roll everything into one. Let's look at it. We'll discuss it. We'll run it and see how it behaves, and so on. Okay. First of all, let's run it. So we compile it. Oh. Compile it, and then we run it. And what it creates is this creates just a simple little window that has eventually we're going to find 4 different things on this GUI. We can see 3 of them now, and when we get the results, we'll see the 4th one. There's a place, there's a label that says enter temperature in centigrade. There's a text box that allows us to enter the info in centigrade. There's a button, and then there is a result label that we can't see now because we haven't done anything yet. But if I type in 0 degrees centigrade, that converts to 32 degrees Fahrenheit, which is right. 100 degrees Fahrenheit or centigrade converts to 212 degree. If we put some garbage in, we get an error that says invalid input. Notice it doesn't blow up. All right? This is getting to the exception handling that we talked about before. Because it's trying to format this text box as a string. If it can't do it, instead of blowing up, it throws an exception, and we catch it, because we can do something about it, right? We can just put a message on the screen saying, hey, you entered it wrong, and then the user can re-enter the input. All right, so let's look at what's going on here. There's only one class. There's sort of at least a couple of libraries that contain stuff dealing with the user interface. 2 of them are Swing and AWT. AWT is older than Swing. If I'm not mistaken, Swing was based on top of it. So I am importing in everything that deals with Swing. That's what Java x.swing means, with the asterisk, means everything. And then I'm importing action listener and action event. And we'll see where that comes in a minute. So my public class first GUI extends JFrame. All right, that's inheritance, remember. So this is a JFrame. Anything that a JFrame can do, this guy can do. And it implements an action listener class. All right. Remember what we said what it means when we implement an interface. What does it mean when we implement an interface? I've called it a contract or a promise. What is this class promising to do? Right. By implementing the interface, this class, this first GUI class, is promising that it will implement all of the abstract methods that exist in Abstract Listener. Well, let's see what those are. Let's go to Java and look for Abstract Listener. Action Listener. All right. Look at our Java docs. There is only one method, action performed. All right? So, what do you suppose this action listener's job is? What role do you think this performs? So, go ahead. To perform an action. All right? What does the word listener, what does that imply to you? Is there where you need it or not? All right? Listener to me implies that it's waiting to hear something. all right? Waiting to hear something. So it's waiting for something to happen. I use the word hear loosely, right? It's waiting for something to happen. It's waiting for an action to happen, and then there's going to be code it's going to execute. If we look at this, what action do you suppose it's waiting for? Clicking the button. Typing in there could be the action it's looking for, but it's not. It's looking for this action. All right? So in other words, the action listener is the code that waits for the user to take some action, and then there's code to process it. Now we could put the listener on any different of our objects on this page. We put the listener on the button. We'll see that in a few minutes here. Actually, we'll see it right now. Our button, we're adding the action listener. That means that we're identifying the code that is going to occur when the user interacts with this button. In other words, what do users do with buttons? They click them. So when the user clicks that button, this is going to be the code that's going to get executed. This is identifying the code that's going to get executed. When I say this class implements action listener, I mean this class can play the role of an action listener. All right? Anywhere that I need an action listener, I can use this very object to do that, this very class. All right? That's what it means to implement an interface. I can use this class because it has all the functions that it needs. In this case, only that one function, action performed. Another way to say it is when I have this class implement the action listener interface, it means that the code to handle the button clicking is going to be in this class. It's not going to be in some other class. All right? That's all that means. We could create a separate class just to listen for the button to be clicked and to do something. But in this case, we're not doing it. Why we're not doing it? It's a real simple example. There's only one button that we're worried about on this page. Why introduce something a little more involved? We're going to let this class be not just the window that displays, but it's also going to contain the code that handles when the user clicks on the button. Okay. That's what it means when I say this implements action listener. If I don't have the action perform method in here, what do you suppose is going to happen when I try to compile it? If I don't have the action perform method in this class, it'll get an error. All right? It'll get an error because first GUI is not abstract and it doesn't override the method action performed. Right? We promised when we said that this implements an action listener that it's going to have all the methods that exist on the action listener. All those abstract methods. Well, in this case, only one of them. There's only one. But we promise that we're going to have that action perform function. And if we don't have it, we'll get an error when we compile it. If we omit this, we omit the line that says that this implements the action listener, we're also going to get a compile error. Because this line here is expecting whatever object it gives, whatever object is given, to implement to be an action listener. If we don't identify this object as being an action listener, then we can't use it in the role of an action listener. So this method here expects whatever this object is here to be an action listener. That is, to implement the action listener interface. If we remove that code from here, then we can't set this object to be this button's action listener. We'll go click undo. Now, with both those things in place, by promising that this guy is an action listener and actually carrying out that promise by having the action perform method, then we can tell the button, hey, this is the object that has your code. When you're clicked, call the action perform method in this class, which is this function right here. Okay? So let's follow this through. The main simply creates one of these objects. That's all that it does. What do? We make the window visible. All right? No big deal. We set the default close operation to exit. What does that mean? Well, when we click this, it exits the app. So that's all that this means. We create a new J panel. All right? Notice that this is a J frame. You know, you think of a frame as being a frame, right? That holds something. You put something in the frame. So you could have a frame, you know, if there was a frame somewhere, we could put all different kinds of pictures in it. We could put a picture in it. We could put our diploma in it. We could put a newspaper article in it, whatever. All right? The frame is simply a holder for us to put something in it. All right? So that's what this is. This is a frame. This is a window. All right? We're now creating a panel. A panel is a thing that we're going to put inside the frame. Okay? So, we're going to put everything on the panel, and then we're going to add the panel to the frame. It's like if we were doing a collage, and we had a blank sheet of paper. We'd glue everything we wanted to the blank sheet of paper, and then that would be our panel, and it would have all the stuff that we wanted on it, and would take that and put it in the frame. So this is simply creating a blank panel for us to put stuff on. All right? Button convert, add action listener. We sort of talked about that a minute ago. I've defined up here the 4 things that I said were on this. A label, a text field, a button, and another label. So that's the 4 things that are going to eventually be in our frame, on our panel, in our frame. All right? So, the button here, which I have created up here, this button is just sort of floating in space at this point. I know that sounds goofy, but it's just in the computer's memory. It's not anywhere on the screen yet until we actually add it to the panel and then add the panel to the frame. But we define the action listener. The action listener is the code that's going to handle when the user interacts with it. And again, we're really only interested if the user clicks on the button. So we set that to this. This class, this object itself is going to contain the code that handles when this button gets clicked. In other words, this code is going to run when the button gets clicked. The code that's in the action performed method on this class, this object, we've said that it's an action listener, so it has to have that method. Because we've implemented that interface, this can serve that function. This can serve that role. So we're plugging this into the button as the action listener, and it's going to handle when the button gets clicked. We then add each of the 4 pieces of the user interface to the panel. We add the label, we add the text field, we add the button, and then we add the second label. The first label has the text, enter temperature in centigrade. The second text field is a text field that allows 4 digits. You notice, though, I could actually type in more. So the 4 isn't like the maximum value. The 4 is how big it makes it. So we could add more than 4. It just sort of scrolls out of the text box. We've created our button that has a text convert. And finally, we've created our results that is going to be a label. We've added all those to the panel. We've added the panel to the frame. The frame has a content pane, and we've added this pane to the frame's content frame. So we put that pane essentially inside this frame. And then just for good measures, we set the side to 800 by 100. So the width is 800, the height is 100. That's why it is wide and not very tall. We do this, the code just sits there until one of 2 things happens. Either the user presses the button, which activates the action performed method, and that does its job, or we hit the little X, which closes, which means that the application exits. Questions so far? Here we have our 4 things. A label is for static text. Now, read-only text that we're not going to allow the user to enter into. A text field is just that, a text field. You can enter text into it. There's nothing in the text field, though, that says that it's going to be a number or a date or something like that. We have to check for that on our own. A button is a button that you can click. Convert is simply the name that's going to be, the label that's going to be on the button. And then finally, our last label is empty to start out. We set the window variable. We say, hey, when you click the X, close out of this. We create a panel to put our stuff. We tell the button, hey, when you're clicked, use this object's action perform method to process your code. We add all those things to the panel. We put the panel in the frame. We set the size, and then we're good to go. Questions about that? Now, when the user does click on the button, it gets passed an argument called action event. It's a argument, action event, and it's called E. That's the name of it. That's the name of the argument. That isn't really relevant here, because I just have one button, one action listener. All I care about is when the user clicks on it. But the action event will give us information about what just happened in case we need it. Let me give you, for example. We could actually have one action listener shared by several buttons. We could have several buttons to do different things. But we could have only one action listener. The action Lister, therefore, would have to be smart enough to know which button got pressed, because there's only going to be one piece of code to handle 3 or 4 or however many buttons. Well, in order to do that, there will be information in that argument, that action event argument named E, that will tell us what button got clicked so that we can go and do our thing. All right? Again, in our case, this is simple. There's only one button. All we're worried about is when the user clicks on it. So we don't really need to look at that event. Think of that event as being sort of like, you know, the police report when there's a traffic accident. All right? It says what happened. It gives you information about what happened. Let's look. What else is contained in it? Tells us what happened. Any modifier keys. So for example, we could have an application where you control click on a button, it does one thing. You shift click on it, it does something else. So if we're interested in that, we could tell by looking at this attribute. GetWhen gives us the exact time that it happened, if that's important. So this tells us what happened. This tells us were there any special keys that were pressed. This tells us when it happened, and this is a string that identifies the event that just occurred. We don't really need that here, because all we're worried about is someone clicking that one button. All right? So when they click that button, I define a couple of doubles, one for C and one for F. So I'm going to convert what's in the text box, I'm going to assume is centigrade, and I'm going to convert the value to Fahrenheit. So I have this in a try-catch block. Why do I need a try-catch block here? Validation? What were you going to say, Kyle? Yeah, it might blow up if it can't convert what's in the text box to a double. All right? I'm not sure if there's nothing in there what it will do. We can test that out. But definitely if I put text in there. Remember, it's a text box, so I can put any characters. So if I put string data in there and click it, this line will fail. If I put Mike in there, this line will fail because I can't convert Mike to a double. If, however, I put a number in there, I can convert it into a double, and then I'll proceed. Remember, anytime you're dealing with user input, likely case for using exceptions, because you don't know what the user is going to put in there. You know? There's like pretty much no chance that these things will go wrong, right? Because this is simply a mathematical expression. This is simply taking our results in Fahrenheit and concatenating them with this phrase and putting it in the results label. But this one could go wrong if the user entered in something that was not numeric. So we try that. If there is an exception, we simply grab that exception and we display a user-friendly message. Invalid input, something that the user would understand. I'm assuming the user would understand that. If we entered in something valid, though, it's going to grab it from that text box. It's going to do the math, get the results in the double named F, and then it's going to take and put that value, F, in the text box. It's going to set the text along with a string that says degrees Fahrenheit. Notice for these text boxes and labels, there's get text and set text, just like we've written gets and sets for all of our classes. Gets gives us the value of something. A set will allow us to change the value of something. So let's make sure everything's okay and run this a few more times. If we play by the rules and put a number in, when we click that button, it grabs that, converts it to a double, does the math, takes the value F, and displays it in there. If we don't put anything in, it tells us invalid input. So you were right. If there was nothing in there, it can't convert that to a double, so therefore it gives us an error. Or if we put in something that is alphabetical, it will tell us that. Questions over any of this? What would happen if we got rid of this try-catch? I'm just going to comment it out. Will it compile? Yes, because this exception, the number format exception, is a unchecked exception. So we don't have to catch it. But it's going to be bad for us because it's just going to blow up and never gives us a chance to correct it and put in the right value. So here, if I compile it, no compile errors, unchecked exception. If I go and I accidentally hit lowercase l instead of the digit 1, I don't think people do that anymore, but back in the old days people did that when on a typewriter that looked like the same as a 1. We can hit convert, and notice what happens. It just blows up. We don't give the user any kind of error. We don't display the correct results or whatever. We want to know that there's a problem. So therefore, we are going to have a try-catch here. So if there is an invalid value, we know about it, and then we can do something about it. In this case, the something that we're going to do about it is display a message and allow the user to re-enter that in. There we go. Questions at this point? That's about as simple of a user interface example as I can come up with. All right. Of course, it goes up from there. Right. We can do a lot more stuff in a user interface. Let's look at the next example. I don't remember what's in it. So we'll find out together. Notice something right off the bat. We still only have one Java class. That's called firstGUI.java. But notice when we compiled it, we got 3 class files. All right? They all start with first GUI. So we have first GUI class, just like we had before. Then we have these 2 classes whose name contains a $sign. And then we have, in that case, a 1, and in this case, C to F. Whenever you see a Java class file that has a $sign in it, that's called an inner class. And we'll see where that comes from in a minute. In other words, firstGUI.java actually contains the code for 3 classes. firstGUI.java, a class called C to F, and then another class that is called an anonymous class because it doesn't really have a name, and therefore it gets a number. So we notice it's called firstGUI $1.class. All right? We're going to look at this example and we'll review the different way that this handles the listener. Because those other inner classes are listeners. All right? Let's take a look at this. All right. This has enter temperature. It has a text box that's really big. I'm not really worried about how it looks right at this moment. All right, so it's really big, but there's 2 buttons on here, C to F and F to C. So if I convert centigrade to Fahrenheit, 22 degrees is 71 degrees Fahrenheit. If I put in 71.6 degrees and convert that to centigrade, tells me it's virtually 22 degrees centigrade. So there's 2 buttons. And the way I did this, I did that with 2 listeners. 2 listeners. So that's our 3 classes. We have the first GUI frame, and then we have a listener for the 1 button, and then we have a listener for the other button. Now, just for demonstration purposes, I created those listeners in 2 different ways. All right? Normally, I wouldn't do that. I'd either use one way or the other. All right? But just to show in one example the 2 different ways that you can create a listener, I did one way, one the other way. So ultimately, when we leave here today, we'll have seen 3 ways to create a listener. One is to make the window itself, the frame itself, implement the action listener interface, in which case then the frame itself can serve in the role of a listener. The other way are the 2 ways that I've seen here. One is with an inner class, the other is with an inner anonymous class. So let's look at this. Most of this is going to be the same or similar. We input something called border layout, which we're going to use at some point. Now, pretty much the top part of it's the same. The only difference is we have now 2 buttons instead of 1. C to F and F to C. Our main method calls the first GUI. I create 2 panels. We'll see how that works in a minute here. I add the 2 buttons to panel 2. I say button convert CF, add action listener, new C to F. Now where is C to F defined? It's defined inside this class. That's why it's called an inner class, right? Because the class definition of C to F exists inside this class definition. Here's this class definition, and it's completely inside the Windows or the frames class definition. It has to implement the action listener method, right? Because in order for us to use this object as a listener for a button, it has to implement the action listener interface, which is a promise that we have an action perform method. All right? You see, when this button gets clicked, it's going to call whoever's action listener was defined for it. It's going to call its action perform method. So we have to know that whoever is the action listener for this has an action perform method. How do we guarantee that it has an action perform method? By making sure it implements the action listener interface. And this code looks exactly like the code in the other example. So this is called an inner class because it's defined completely inside of it. So in this case, this guy no longer needs to implement the action listener interface because this guy isn't the guy that has the code that contains the action perform function. It's inner class. C to F has that code. Now, here I do something that you'll see a lot in bigger examples, like if you do Android examples or whatever. This is called an anonymous class because this class doesn't even get a name. It's simply a new action listener, and we can define the function like this without even creating a full-blown class that has a class name and anything like that. So this is just a shorthand, all right, to say, hey, the code is going to handle this guy's actions is an action listener that contains this function. And that function is pretty much identical to the C to F function, except it does the opposite calculation. All right. You can ignore this because it's commented out. I have 2 panels here. I can put 2 panels inside my frame. The first panel, P, I set as having a box layout along the y-axis. All right, let me go over what that means. A box layout is where each thing in the panel, you're going to think about it as being a little box. And it's just going to be stacked on top of each other. It can be stacked vertically or along the y-axis or horizontally by the x-axis. Now, in this case, I set for P, I set it having a new box layout along the y-axis. That's horizontally. I said the one thing and I did the other thing with my hand. It's vertically. The default is horizontal, because we didn't do this in the last example. We got it horizontal. But we set this one to be along the y-axis, which is vertical. What do we put in to that panel? We put into that panel the label for the temperature, the text box for the temperature, panel 2, and then the label results. So let's draw what's happening here. This is our panel P. We have floating in space now a label, a text box, a panel called P2, and another label. All right? That's the stuff that we have here, floating in space. I've added to P2 both buttons, 2 buttons. Oh, I forgot to draw these 2 buttons. I haven't set the layout for this P2, so by default it's horizontal. So I have my 2 buttons living inside of panel 2. I then add to my main panel, P, the label, the text box, P2, and the other label. So I add the label, the text box, P2, which contains both buttons, and then finally the label for the results. So that's what my frame should look like after we set the content pane to P, and we set the size to be 800 by 150, and we set the visibility to true. So if we look at this, sure enough, that's what this looks like. Now, it's kind of goofy that that text area goes all the way across the screen, and we're not going to worry about that right now. If I put something in here, click one button, I get the one action listener. Click the other button, I get the other action listener. All right? I think the important takeaway from this is how we create the different little views that we're going to have on the page, how we put them on panels, put the panel inside the frame, and most importantly, how we can associate with different things on our screen an action listener that waits for the user to interact with it and then has some code that does something depending on what the user does inside of it. All right, that's where we'll pick up next time. Any questions? All right, we'll see you in lab.